Hi, I want to make this short video about what are basic feasible solutions and what's the optimal basic feasible solution in linear programming. And I want to do it according to an example we had at college, which is minimize C transposed X subject to these constraints. Now, a basic feasible solution is a solution for which n constraints, n linearly independent constraints, are satisfied with an equal sign. So first, what do I mean by linearly independent? Or better, let's rewrite these constraints differently. We can rewrite this as x1 smaller than 1 and for x1 greater than 0. And we can do that to xn smaller than 1 and xn greater than 0. And what you see here is obviously these two are linearly dependent because we can get from this value to this value simply by multiplying by 1. But we can't get from this value to this value, right? So what we then have to do is let me write this one more time a bit differently. I will write this one as x1 plus x2 plus xn smaller than 0, and now I put here this 0. So, and the next one is x1 plus 1 x2 plus plus xn smaller than 1, and this is like this. So now we can see the linearly independence a bit better. Like these two are obviously linearly independent. And now let's put this below here. So we can write 1x1 plus 0x2 plus plus 0xn is greater than 0. And with the equally we can write the other ones. And now you can see from this one, we can obviously get to this one, right? So these two are obviously linearly dependent. And to get a basic feasible solution, I write this now as BFS, basic feasible solution, n linearly independent solutions, feasible solutions, and feasible solutions are just solutions which satisfy this constraint, right? With I don't know, 0.5, 0.2, 0.3, 0.7, that really doesn't matter. But in basic feasible solutions, we only want the n constraints which satisfy this constraint with an equal sign. So we don't want 0.5, we don't want 0.3 in this case. We only want these solutions which fulfill the constraint with equal. So n linearly independent feasible solutions. No, feasible. That's not feasible. No? Constraints, n linear independent constraints satisfied with equality. Now, what does that mean for our constraints? So we just take for so we want all BFS. So we want to know what are all BFSs and what is the optimal BFS. So let's just take that we see one. We take the first n. So we know we have two n constraints, right? The first n are all the constraints smaller than 1, and the second n are all greater or equal to 0. So what we do is we set the first n equal to 1. So x1 equal to 1, x2 equal to 1. So, and now it's obvious that the other ones, the other n, the ones below which are greater than 0, they obviously true because 1x1 greater than 0, 1, when we input 1 here, this is obviously true. For all other n, it's obviously that when we input here every 1 everywhere, it's obviously greater than 0. So that would be 1. Now we want all BFS, right? So since we can input here for each x1 or xi 0 or 1, and we will always be true and we want all of them, we can only input 0 or 1, right? Because if we would input 0.2, for example, here in x1, it would obviously be true for non-equal with that, right? It's smaller than 1. But if we don't fulfill this one with an equal sign, we must fulfill the one below here, right? This one with an equal sign. But we have here 0.2, and that's obviously equal to 0. So we have for each xi a possible value of 0 or 1, and we have n constraints, so we have obviously 2 to the n basic feasible solutions, which look all like x1 to xn with xi equal to 0 or 1, right? Now now let's look at our constraint with ct of x must be minimize ct to x, c transpose to the x. Let's think about it for a moment. We want as low a value as low as possible. So if we know that c is r to the n, we can have negative values. So what we do is we just take, if we have negative values, we take them as 1, and if we don't have negative values, we take zeros, right? So we take the solution, optimal basic feasible solution, x is equal to t1 tn, and ty is equal to 1 if ci is smaller equal to 0, and it's 0 if c1 is greater than 0, to get a low solution as possible. And this, now we have to check, is this even a basic feasible solution? And of course it is, because we only input 1 or 0 here, and we know that we have every possible combinations of 0 and 1s. So this would be one we had in our college. And for the ones more interested, I could suggest another one which is pretty similar. It's like minimize ct of x subject to 1 transpose, which I mean just a vector full of ones, right? X equal to 1 and x greater than 0, which is also a vector. Yes. So thanks for watching, and you obviously, with the knowledge of above, you obviously should be able to solve this new one here, which is pretty fun. So thanks a lot for watching. Have a nice day. Bye.